Right now, in this exact moment, something extraordinary is happening to you. You don't feel it, you don't hear it, you don't see it, but you are falling. Not downward, not upward, not in any direction your senses can describe. You are plunging through the fabric of space itself, carried by a motion older than stars. Your body, your home, the ground beneath your feet, the entire Earth is in a state of free fall, wrapped inside a silent cosmic descent that has been unfolding for billions of years. Our planet is not sitting in the void like a stone in still water. It is rushing forward at nearly 30 kilometers every second, tracing a vast curve around the sun, a fall so precise and stable it never ends. And the sun, immense and burning, is also falling. It is plunging through the Milky Way, swept along by the gravitational currents of our galaxy, dragged toward an unseen gravitational basin so massive it bends the motions of hundreds of billions of stars. Every planet, every moon, every comet, every drifting cloud of cosmic dust is caught inside this same descent. We call it orbit. We call it motion. But beneath those familiar words lies a deeper truth. Everything in the universe is falling. Gravity is not just the force that drops an apple from a branch. It is the architect of cosmic structure. It decides where stars ignite, where galaxies drift, where time flows slowly, and where it rushes ahead. It carves the hidden geometry behind every path traced across the night sky. But what does it mean to fall in a place where there is no down? How can something fall forever without ever hitting the ground? And what exactly are all objects falling into? To answer that, we have to step beyond everyday intuition and enter the deeper engine behind the cosmos. Because falling is not a story about a force, it is a story about a current, a cosmic river, guiding planets, stars, galaxies, and even time itself. And we are all inside it. The universe doesn't stand still. It flows. It collapses. It falls. We imagine falling as something simple. A pebble slipping from a palm, a leaf spiraling to the ground, a droplet sliding down a window. But these are only local expressions of a far greater truth. Falling is not what happens when support is removed. Falling is what happens when an object finally follows its natural path through space-time. Right now, you are falling toward the center of the Earth. You don't feel it because the ground pushes back, interrupting the fall that has been present since long before you were born. Remove the ground, and you wouldn't begin falling. You would simply stop resisting the motion already there. That is free fall. When you step off a ledge, you aren't creating a new motion. You are surrendering to the one that has always existed. When astronauts float in orbit, they are not escaping gravity. They are obeying it with absolute precision. The spacecraft, the equipment, their bodies, everything inside is falling together. Weightlessness is not the absence of gravity. It is the absence of resistance to gravity. Orbit is free fall perfected. Imagine throwing a ball forward. The faster you throw it, the farther it flies before touching the ground. Throw it fast enough, around 28,000 kilometers per hour, and the Earth curves away beneath it as quickly as the ball falls. It keeps missing the ground. It becomes a satellite. A satellite is a rock that never reaches the Earth because the Earth is falling away beneath it at the same pace. This idea is so wildly counterintuitive that it took humanity millennia to understand it. To us, falling has always meant down. But in the language of the universe, down does not exist. There is only the curvature carved into space-time by mass. Orbit is not the opposite of falling. It is falling, seen from a higher viewpoint. The moon is not hanging in the sky like a lantern. It is plunging toward Earth every second. But Earth curves away just as fast, turning that fall into a loop that has lasted 4.5 billion years. And the same is true for us. Every ocean, every mountain, every city, every heartbeat is falling toward the sun. We don't crash into it because the Earth moves sideways fast enough to keep missing. We don't stand in space, we swing through it, suspended in an eternal, graceful descent. Gravity does not push, it does not pull, it shapes. Objects follow the paths space-time allows. Orbit is not a suspension, it is harmony. The perfect balance between an object's motion and the shape of space-time around it. This balance is the reason we have seasons, the reason temperatures remain stable, the reason oceans don't evaporate or freeze solid, the reason life had time to evolve. If Earth's orbital speed were slightly slower, we would spiral inward and be consumed by the sun. If it were slightly faster, we would sling out into interstellar darkness, frozen and dead. We live inside a razor-thin margin of stability. This is the quiet, astonishing truth. We are falling around the sun with such perfection that life can exist. But before Earth could orbit the sun, it first had to fall into the sun. Long before there were planets or oceans or skies, long before blue light scattered in our atmosphere or continents drifted across the molten stone, there was only a cold, starless cloud drifting through the galaxy. A vast, dark nebula of hydrogen, helium, and cosmic dust. To the naked eye, it would seem still, but gravity was already whispering inside it, tugging at every atom. Where the cloud was slightly denser, gravity pulled harder. Where gravity pulled harder, matter gathered. And where matter gathered, the gravitational pull deepened. Slowly at first, then faster, an unstoppable collapse began. A runaway fall. As the cloud contracted, it started to spin. Angular momentum demanded it. Just as a figure skater spins faster when pulling their arms inward, the collapsing cloud rotated more quickly. It flattened into a disk, a cosmic whirlpool spiraling inward. At the center, pressure climbed. Temperatures soared. Hydrogen atoms crashed together with such violence that nuclear fusion ignited. A star was born. The sun was not placed in the sky. It was forged by collapse, born from the weight of gravity crushing a cold cloud into fire. Around it, the remaining debris continued to fall, collide, fuse, fracture. Dust became stones. Stones became mountains drifting in orbit. These protoplanets collided violently, merging into larger worlds. Gravity sculpted them into spheres, sorted their orbits, carved structure from chaos. Earth is a fossil of that ancient collapse, a solid memory of the moment gravity pulled order from dust. And that ancient fall never stopped. The sun still pulls. The planets still descend in their silent loops. Comets still dive inward like icy echoes from the cloud we came from. Gravity has no plan, yet it builds stars. It has no intention, yet it arranges planets. It has no design, yet it creates systems capable of supporting life. Falling is not destruction. Falling is creation. But every star lives with a ticking clock. A star exists because fusion pushes outward as gravity pulls inward. A cosmic tug-of-war that can last billions of years. But no fire burns forever. When the fuel runs out, the outward pressure fades. Gravity does not. The star collapses, inward, accelerating, unstoppable. The core shrinks. Atoms are crushed. Electrons merge with protons. Neutrons compress. If the star is massive enough, even neutrons cannot resist the weight. The collapse breaks through the limits of matter itself. Space-time caves in. A singularity forms. A black hole is born. A black hole is not an object. It is a place where falling becomes destiny. Inside the event horizon, every path leads inward. There is no sideways escape. No stable orbit, no resistance. Even light cannot outrun the fall. From the outside, a black hole looks deceptively calm, but near its edge, the laws of physics twist into impossible shapes. Time slows, space stretches, light redshifts into darkness. A falling object appears frozen in place. But from its own perspective, nothing unusual happens. It crosses the horizon without drama, and then continues falling forever. Black holes are gravity's purest expression. The final chapter of collapse, the end point of falling with no ground left to hit. And they are everywhere. Some are the remnants of dead stars. Others, like the one at the heart of the Milky Way, contain millions of suns. They are the gravitational engines that shape galaxies. For a long time, we imagined galaxies as islands drifting peacefully. But the universe has never been peaceful. Every star falls. Every planet falls. Every galaxy falls. Our Milky Way is being pulled toward something enormous and unseen. An immense gravitational anomaly called the Great Attractor. We cannot see it directly. It hides behind thick clouds of dust and starlight. But its pull is unmistakable. Our entire galaxy is sliding toward it at over 600 kilometers. We don't feel this motion because everything around us, the sun, Earth, our bodies, is moving with us. We are passengers on a galactic current, and this current flows into something even larger. The Laniakea supercluster, an enormous basin of gravity defining a region 500 million light-years wide. Galaxies here don't orbit anything. They fall through a gravitational landscape. This is the universe on its largest scale. Webs of galaxies flowing along colossal gravitational slopes. But when astronomers tried to understand galaxy motion, they discovered something impossible. Stars in galaxies were moving too fast. Far too fast. The outer stars should have flown into space long ago. But they stayed. Something invisible was holding them together. Dark matter. It does not shine. It does not absorb. It does not interact with light at all. But it has mass, and mass means gravity. Every galaxy sits inside an enormous halo of dark matter. The stars we see are just the luminous icing on a much larger invisible structure. Dark matter is the skeleton of the universe. It guides galaxy formation. It shapes clusters. It controls how galaxies collide. It defines the cosmic web. And the cosmic web is the universe's largest structure. A vast network of filaments, billions of light-years long. In the beginning, the universe was smooth, almost perfectly smooth, but not entirely. Tiny ripples in density, created in the first fractions of a second, provided the seeds. Gravity amplified those ripples, turning them into basins, then into rivers of matter. Matter slid inward. Filaments formed, clusters grew, superclusters emerged. The universe sculpted itself through falling. Everything, from the orbit of Earth to the drift of galaxies, was encoded in those early patterns. The universe has never stopped falling. And this falling drives not just motion, but time itself. Time has a direction because entropy increases. A shattered glass never reassembles. Smoke never unburns. Stars burn fuel and never regain it. And entropy, the driver of the arrow of time, is deeply tied to gravity. The early universe was smooth, which means low entropy. But gravity amplifies unevenness. It turns smoothness into structure, structure into collapse, collapse into stars, stars into black holes. A black hole contains more entropy than the entire galaxy around it. The arrow of time is written in gravity's handwriting. Falling forward is time moving forward. If the universe had remained perfectly smooth, time might still exist as a coordinate. but nothing would happen. No complexity, no stars, no planets, no evolution, no history, no life. Gravity gave time its drama, its momentum, its direction, its meaning. And right now, as you read these words, you are part of the same cosmic descent. From the first quantum fluctuations after the Big Bang, to the swirling motion of galaxies, to the orbit beneath your feet. The universe is falling. Everything in it is falling. And you are falling too, carried silently through a cosmic landscape shaped by gravity, motion, and time. Once a star is born, once matter has clumped and crossed that invisible threshold where fusion ignites, the universe has taken a step it will never undo. There is no going back to the smooth, quiet state that came before. Every collapse, every ignition, every gathering of matter is a decision written into the fabric of time. Even black holes, those dark endpoints of gravitational collapse, are not empty. They are overflowing with entropy. The disorder locked inside a single black hole can exceed that of all the stars in an entire galaxy combined. In a strange twist, the greatest leap in cosmic disorder doesn't happen when things break apart, but when they fall together. The arrow of time isn't just written in shattered glasses, burned fuel, or dying stars. It is etched into the way the universe falls. Every collapse, every merger, every orbit slowly losing energy is a one-way journey forward. The universe began in an incredibly low entropy state, smooth, uniform, balanced on a knife's edge. From that moment on, gravity has been guiding it toward higher entropy, toward structure, toward collapse, toward the slow spreading of energy. Falling is not just motion through space. Falling is how time unfolds. If the universe had never fallen, if matter had never clumped, if clouds had never collapsed, if stars had never formed, time might still exist as a coordinate you could label. But it wouldn't feel like time. There would be no stars to live and die, no light to shine, no galaxies to spin, no planets to evolve, no history to write. It is the act of falling, structure forming, entropy rising, that gives time its direction. The universe falls forward, and so does time. Every heartbeat you feel, every breath you take, every sunrise you've ever seen, all of them are possible because Earth is falling. That's not poetic metaphor. That's literal. Gravity is the silent architect of everything life depends on. It shapes the star we orbit. It fixes our distance from that star. It holds the thin film of air that keeps us alive. Our planet is trapped in a precise gravitational dance around the sun. This isn't a lucky accident. It's a requirement. Too close, and the oceans would boil, the atmosphere would strip, and the surface would bake sterile under unfiltered radiation. Too far, and the oceans would freeze solid, the air would condense, and the world would fall silent beneath an icy sky. We live in a narrow, habitable zone, a fragile equilibrium set by the interplay between sunlight and falling motion. Earth follows a curve through space-time that delivers just the right amount of energy, averaged over time, for liquid water to exist and chemistry to thrive. Falling along the right curve is the only reason life has a chance. Gravity also holds our atmosphere in place. Without it, air wouldn't cling to the planet. It would simply drift away into space, molecule by molecule. Every breath you take, every molecule of oxygen in your lungs, every trace of nitrogen, carbon dioxide, and water vapor, all of it is here because Earth's gravity is strong enough to keep it. Every breath is borrowed from a gravitational well. But the role of falling goes deeper than the sky. Inside Earth, gravity is not just a gentle pull. It is a relentless squeeze. It presses rock and metal together, driving convection in the molten outer core. That churning, electrically conducting metal generates a magnetic field, an invisible bubble that wraps our planet, deflecting deadly solar wind and cosmic particles. Without that shield, the atmosphere would be stripped away over time. The surface would be bathed in radiation. Life might never have started, or never survived. Gravity sets the pace of our days and seasons too. The tilt of Earth's axis, the shape of its orbit, the subtle pull of the moon, all of these are orchestrated by falling. These cycles regulate climate, tides, and ocean currents. They create a kind of long-term stability. The one thing complex life needs more than anything else: time. Even the sun itself, the source of all our surface energy, exists because gravity once collapsed a cold cloud into a burning star. The warmth you feel on your skin during a clear day began as a fall billions of years ago. Every living organism is running on the stored energy of an ancient collapse. And gravity doesn't just make worlds habitable. It holds them together long enough for life to emerge and evolve. Stars burn for billions of years because fusion and gravity are locked in balance. Planets trace stable orbits for eons, giving evolution time to experiment, fail, and try again. Tides from the moon's pull may have nurtured the first fragile ecosystems on the edges of ancient seas. Life isn't a disruption of the universe's falling motion. Life is a pattern shaped by that motion. We are not separate from the fall. We are its consequence. When you stand on solid ground and look up at the night sky, you're not just seeing distant stars. You're looking at the infrastructure that makes your existence possible. A planet held together by gravity, bathed in the steady light of a star born from collapse, shielded by magnetic fields forged in a churning core. Without gravity, there would be no stable orbit, no persistent atmosphere, no long-lived sun, no oceans, no chemistry that can keep going long enough to call itself alive. Falling is not the enemy of life. Falling is the reason life exists at all. And gravity doesn't stop at the surface. It reaches inward, all the way to the heart of the world. When Earth first formed, it was nothing like the calm blue marble we know today. It was a storm of fire and stone, a chaos of impacts. Asteroids slammed into each other. Dust gathered into rocks, rocks into mountains of rubble, and each impact added more mass. With more mass came more gravity. That relentless pull crushed the growing world under its own weight, heating it from within. That ancient heat never completely faded. Gravity keeps it alive. Deep beneath your feet, the pressure is unimaginable. Iron and nickel are crushed into a dense core. Temperatures there rise higher than the surface of the sun. This is not just leftover warmth from formation. It is gravity at work, again and again, converting the energy of countless falls into a furnace beneath our world. Inside that furnace, the molten outer core flows and churns. Heat rises, cool material sinks, and this endless circulation of charged metal creates Earth's magnetic dynamo, the field that shields us from the sun's charged particles, that keeps our atmosphere from being peeled away. Above the core lies the mantle, a vast layer of rock that behaves like a very slow, very thick fluid on long timescales. Here, gravity drives another kind of motion. Hot material rises toward the surface. Cooler material sinks back down. This slow overturn, mantle convection, is the heartbeat of the planet. That heartbeat pushes and pulls on the crust above. It shoves continents together and tears them apart. It opens new oceans and closes ancient ones. Mountains rise, plains sink. The continents beneath your feet are not fixed. They drift at roughly the speed your fingernails grow, over millions of years, crossing entire oceans. Every movement is powered by heat. That heat is held, concentrated, and sustained by gravity's squeeze. Volcanoes erupt because hot plumes punch upward through the crust. Earthquakes strike because plates grind, lock, and slip. These violent events may look like random catastrophes, but they're part of a deep, organized circulation that gravity set in motion billions of years ago. And this hidden engine does more than sculpt the surface. It feeds life. Volcanoes recycle carbon from rocks back into the air and oceans, regulating climate over millions of years. Plate tectonics creates new habitats, reshapes coastlines, and drives nutrient cycles. It helps keep temperatures within a range where liquid water and life can persist. The world beneath us is not dead rock. It is alive in a gravitational sense. Even the oceans depend on this interior engine. Gravity holds the pressure that keeps Earth's interior active. If our planet were too small, gravity too weak, the core would have cooled quickly. No long-lasting molten core, no magnetic field, no plate tectonics, no long-term climate stability. Without that inner fall, the outer world would be very different, and very likely lifeless. We often look up when we talk about gravity, to orbits, to stars, to galaxies. But some of gravity's most important work is happening in the darkness far below our feet. Every mountain range, every tectonic ridge, every plume of rising magma, every drop of molten iron spinning at the core. All of them are expressions of the same story. Falling built the planet, and falling keeps it alive from the inside out. But worlds don't last forever. Even the most vibrant planet will eventually grow quiet. Its fires will fade, its core will freeze. Its gravity will remain. Gravity never turns off. But its internal heartbeat will stop. Inside every rocky planet, heat is a memory of ancient collisions, relentless compression, and gravitational energy trapped deep within. Over billions of years, that memory fades. As the interior cools, the liquid core becomes sluggish. Convection weakens. The dynamo that powers its magnetic field sputters and dies. Without that magnetic shield, the solar wind begins its slow, patient work, stripping away the atmosphere particle by particle, bleeding the sky into space. Unfiltered radiation scorches the surface. Water evaporates and is lost. Temperatures swing between brutal extremes. A once active world grows bare, cold, and quiet. We can see this story written across our own solar system. Mars almost certainly once had rivers, lakes, perhaps even a shallow ocean. It had a thicker atmosphere, a warmer climate, a more dynamic past. But its smaller size meant its core cooled more quickly. Its magnetic field faded. Unprotected, its atmosphere was slowly stripped away. Today, it is a frozen desert under a thin, fragile sky. Mercury tells another version of the same tale. A small, dense world. Its internal motion has largely ceased. Its surface is seared on one side, frozen on the other, with only a weak magnetic whisper left. When a planet still has an active interior, it can shield itself, regulate its climate, and reshape its surface. When gravity inside goes quiet, that world begins to age in silence. This is the slow death of a planet, not a dramatic explosion, but a cooling and a fading. Mountains stop growing. Volcanoes go extinct. The sky thins. The ground freezes. The world forgets it ever burned. Earth will face this too. One day, our core will cool. Our magnetic shield will weaken. Tectonic plates will grind to a halt. Long before that, the sun, swollen into a red giant, will remake the inner solar system. The falling inside will finally stop. The falling outside will take over. A cold planet is not a planet without gravity. It is a planet where the energy released by gravity's ancient fall has finally run out. Gravity built the world. Gravity kept it alive. And in the end, gravity watches as its creation grows quiet again. Everything that falls has an end. A planet cools. A star burns out. A galaxy drifts and merges. And one day, even the universe itself will grow old. Right now, gravity still rules much of the cosmic stage. It builds stars from gas. It shapes galaxies. It draws clusters together in slow, silent rivers of motion. But gravity can only sculpt where there are differences in density. Hills and valleys in space-time for matter to slide down. As time stretches forward, that landscape begins to flatten. Stars burn their fuel and fade into white dwarfs, neutron stars, and black holes. Black holes devour what they can and then wait in the dark. Galaxies drift farther apart, carried on the swelling tide of cosmic expansion. The universe grows colder, thinner, quieter. Trillions of years from now, new stars will no longer form. The last red dwarfs, the longest-lived stars, will dim and die. The great engines of gravity will fall silent, not because gravity disappears, but because there is nothing left that can fall in any meaningful way. Even black holes, the ultimate monuments to collapse, will not last forever. Through Hawking radiation, they slowly leak their mass away. Over unimaginable timescales, they evaporate, leaving behind only a thin mist of low-energy particles. This is the heat death of the universe, a time when entropy is maximized, when energy is smeared evenly across an enormous, nearly empty cosmos. There are no more gradients to drive motion, no higher or lower places in energy for things to fall between. It isn't an explosion. It isn't fire. It is the opposite. A stillness so complete that the concept of falling loses its meaning. Gravity will still be encoded in the geometry of space-time. The equations will still hold, but there will be nothing left for gravity to organize. No clouds to collapse, no stars to ignite, no orbits to maintain. Every gravitational well will have flattened into a nearly featureless plane. The universe won't end with a bang. It will end as a long, slow exhale, a fade into perfect, silent equilibrium. This isn't tragedy, it's consequence. Every orbit, every collapse, every heartbeat of gravity has been moving energy from order to disorder, from sharp differences to smooth sameness. The arrow that began as a whisper at the dawn of time ends in a quiet, endless sigh. The cosmos began hot, dense, and uneven enough for gravity to work with. It ends cold, diffuse, and almost perfectly smooth. And somewhere between those two infinities, everything we know, every star, every planet, every thought, every life, is just a moment in the universe's long fall toward stillness. For most of cosmic history, gravity has seemed invincible. It gathered dust into stars, stars into galaxies, galaxies into clusters, clusters into the great rivers of the cosmic web. It felt like gravity would define the universe forever. Then we discovered something else. Billions of years after the Big Bang, astronomers measured the light from distant supernovae and found something astonishing. Galaxies weren't just drifting apart. They were accelerating away from each other. Space itself wasn't just expanding, it was speeding up. This wasn't gravity's doing. It was the sign of something different, something that behaves like a kind of pressure built into the fabric of space-time. We call it dark energy, a name that mostly admits how little we understand it. Dark energy is not a force that pulls objects together. It does the opposite. It stretches the stage itself. Imagine standing on a rubber sheet that's expanding beneath you. No matter how hard you try to run towards someone far away, The sheet between you stretches faster than you can close the gap. On small scales, gravity still dominates. Planets cling to stars, stars cling to galaxies, galaxies cling to clusters. But beyond those islands of stability, dark energy takes over. Space expands faster and faster, carrying distant galaxies beyond each other's reach. Over time, more and more of the universe will slip past our cosmic horizon. Not because those galaxies are speeding through space, but because space between us is swelling too quickly for their light to ever arrive. One by one, the lights will go out. Eventually, only our local group of galaxies, the Milky Way and its neighbors, long since merged into a single mega-galaxy, will remain visible. Everything else will have vanished beyond our horizon, erased not by destruction, but by distance. This is gravity's quiet defeat. Falling requires contrast, high and low, dense and diffuse, near and far. Dark energy smooths those differences on the largest scales. It stretches everything apart faster than gravity can pull together. Gravity will never vanish, but its kingdom will shrink. The universe will not stop falling, but the falls will become small, local, and isolated, surrounded by a vast, accelerating emptiness. We began this journey with something simple: a stone dropping, an apple falling, a planet orbiting, a galaxy drifting. What looked like stillness was never still. Everything moves. Everything is pulled. Everything falls. You are falling right now, around the sun, through the galaxy, along a gravitational river flowing toward distant structures you will never see. The ground beneath you doesn't hold you still. It simply pushes back against the path gravity is asking you to take. The stars overhead are falling too. They orbit invisible centers, slide along dark matter filaments, and trace out curves through the cosmic web. Even that web was born from faint ripples in the early universe. Tiny imbalances that started the great cascade of falling and structure. Every structure that exists is a monument to falling. Planets formed because dust fell inward. Stars ignited because gravity squeezed. Galaxies gathered because the universe was uneven. Black holes emerged where the fall never stopped. Falling shaped our world from the inside as well as outside. It forged our molten core, our magnetic shield, our atmosphere, our oceans. It gave us a stable orbit, a steady star, and a climate with enough consistency for life to arise and persist. But even falling has limits. Entropy grows, energy spreads. Dark energy stretches the arena itself. Gravity's reach shrinks. One by one, the great structures of the universe will drift beyond each other's sight, not because gravity failed, but because the stage beneath it changed. The universe began in a fall, matter collapsing out of smoothness into structure. And one day, it will end in stillness, a flat, quiet, almost featureless sea. Between those two extremes, falling gave us everything: every star, every orbit, every storm, every forest, every mind that ever looked up and wondered why. We are a brief, bright pattern in the middle of that descent. Everything falls. And we are part of that fall, not watching from the outside, not separate from it, but carried within it, written into it. In the end, that's what makes our moment in the universe so precious. We exist while the cosmos is still falling. Every ice age, every green explosion of life between them, every glacier that crawled across continents, and every forest that reclaimed the land after the ice retreated. All of it has been conducted by something you cannot see when you look up at the sky. Not a sudden catastrophe, not a random whim of weather, but tiny, predictable shifts in Earth's orbit. Over tens of thousands of years, our planet's path around the sun doesn't stay exactly the same. It stretches a little more into an ellipse, then rounds back toward a circle. Its axis tips a little farther, then leans a little less. The direction that axis points slowly wobbles, tracing a slow circle in the sky. These are the Milankovitch cycles, the quiet machinery of climate written in orbit. Each change is small. A few percent more sunlight here, a few percent less there. Winters slightly colder, summers slightly warmer. Or the opposite. On human scales, it feels like nothing. But give those tiny orbital nudges tens of thousands of years to work, and they can flip entire climate regimes. A slightly cooler summer in the north can let winter snow survive a little longer. Survive long enough, and it becomes ice. Ice reflects more sunlight, cooling the planet further. Feedbacks pile up, and Earth slides into an ice age. Shift the orbit again, and the opposite happens. Summers grow stronger, ice melts, dark oceans and forests soak up sunlight, and the planet warms back into an interglacial bloom. The deep breath in and out of ice and thaw is not random. It is paced by the way Earth falls. These cycles don't act alone. They talk to everything else, to ocean currents that shuffle heat around the globe, to the chemistry of the atmosphere, to the ice sheets that brighten or darken the planet's face. But orbit is the metronome. Doesn't write the melody, but it sets the tempo. With each shift, Earth redraws its coastlines. Ice carves valleys and leaves behind lakes. Sea levels fall and rise, revealing land bridges and then drowning them. Entire ecosystems advance and retreat, following the moving frontiers of cold and warmth. Even the story of our own species is written along those changing lines. Migrations out of Africa, refuges in ice age bottlenecks, expansions during warm periods. The path our ancestors walked was traced on a world whose climate was being tuned from above. Orbit doesn't just give Earth stability, it gives Earth rhythm. A long, slow cosmic heartbeat that pulses beneath everything we know. From the surface, that heartbeat feels eternal. Every year, Earth seems to return to the same spot around the sun. The seasons repeat. Spring follows winter, summer follows spring. It's easy to believe our orbit is a fixed track, carved into space once and for all. But nothing in the universe is truly permanent, not even the curves that hold us. On short timescales, orbital changes are tiny, almost invisible. But stretch the clock to hundreds of millions or billions of years, and the map begins to warp. Planetary orbits are not rails. They are compromises, truces between gravity, motion, resonances, and chance. One of the main forces changing Earth's orbit over deep time isn't even external. It's our own star. Stars are not steady lamps. They are evolving reactors. As the sun burns hydrogen into helium in its core, its structure changes. It very slowly brightens and swells. Over hundreds of millions of years, its luminosity creeps upward. In about 1 billion years, the sun's output will be roughly 10% higher than it is today. That doesn't sound like much. 10% is the sort of change you barely notice on a light dimmer. But Earth sits in a precarious energy balance. That small increase is enough to push us toward the edge. As the sun brightens, the habitable zone, the comfortable shell around a star where liquid water can exist on a planetary surface, will move outward. The orbit we occupy, which is now perfectly placed within that zone, will become a little too hot, a little too aggressive. Oceans will evaporate faster. More water vapor will fill the atmosphere, trapping more heat. That, in turn, will drive further evaporation in a runaway loop. At some point, Earth enters a moist greenhouse state. The sky thickens with steam. The upper atmosphere fills with water molecules that can be split by solar radiation and lost to space. Our oceans, the stabilizers of climate, the cradle of life, will slowly boil off into the void. Long before the sun becomes a red giant and physically reshapes the inner solar system, the gentle drift of its brightness will have rewritten the meaning of Earth's orbit. The curve through space will be the same. The conditions that curve sustains will not. Earth will still move in free fall, still follow a graceful path around its star. But that path will no longer be home to oceans, clouds, forests, or people. The orbit survives. The world we know does not. Meanwhile, gravity keeps playing its long, patient game. Planets tug on each other as they circle the sun. Those tiny gravitational pulls accumulate over eons. They tweak orbital eccentricities, tilt axes, shift resonances. Computer simulations of the solar system, run forward for billions of years, show a small but real chance that the inner planets could eventually slip into chaotic motion. Most likely, things stay mostly orderly. But there is a non-zero possibility that Mercury could be flung into a new orbit, that Mars could be ejected, that collisions between worlds could happen in the deep future. Even without drama, the shapes of the orbits slowly evolve. The solar system we know is not the solar system that will exist 5 billion years from now. And then, eventually, there is the sun's own ending. Roughly 5 billion years from now, its quiet increase in brightness will be over. It will run out of easily fusible hydrogen in its core. Gravity will win again, the core will contract and heat, and the outer layers will bloat outward. The sun will swell into a red giant. As it expands, it will shed mass in great stellar winds. Less mass means weaker gravity. Weaker gravity means the orbits of surviving planets will expand outward. Earth's orbit will drift away as the sun lightens and swells. Whether our planet is engulfed by the sun's outer layers or merely scorched into a molten husk that circles a swelling fireball is still a matter of detail. But either way, by that point, whatever Earth once was is gone. Its orbit will be there, but only as a memory traced in rock and vacuum. Eventually, the sun will cast off its outer layers completely, leaving behind a dense white dwarf, a faint ember roughly the size of Earth, but with half the sun's mass. Around this cooling corpse, whatever fragments of the solar system remain will settle into new orbits, stretched, slower, quieter. A few asteroids, perhaps icy bodies, maybe the skeletal remains of planets. A ghost system orbiting a ghost star. Orbit is not immune to time. It evolves with the stars it serves, nudged by neighbors, reshaped by stellar death. Even the most stable path is just a chapter in a longer story. The curve that holds us today will not hold us forever. But this unraveling doesn't stop with stars and planets. Right now, gravity is still the main sculptor of motion on large scales. It holds galaxies together in clusters, clusters in loose superclusters, and guides everything along the filaments of the cosmic web. But gravity has an opponent: dark energy, the mysterious pressure built into the fabric of space-time. For billions of years, gravity and expansion have lived in a kind of uneasy compromise. On small scales, gravity dominates, building galaxies and clusters. On the largest scales, the expansion of the universe spreads everything out. Now, dark energy is slowly tipping that balance. As the expansion of the universe accelerates, gravity's reach shrinks. Galaxies that are not tightly bound to us are carried away faster and faster by the stretching of space. Far in the future, all galaxies beyond our local group will slip beyond the cosmic horizon. The distance beyond which light, no matter how fast it travels, will never reach us. Not because those galaxies have done anything dramatic, but because the space between us grows too quickly for their light to bridge the gap. Their orbits around larger structures will simply stop mattering. They will be dragged along by the expansion of the universe like leaves frozen in ice. The cosmic web will thin. Filaments will stretch and snap. Clusters that once orbited one another through the invisible valleys of dark matter will become isolated islands, each surrounded by an ocean of darkness it can never cross. Inside these shrinking islands, the old motions will continue for a while. Stars will still orbit galactic centers. Planetary systems will still trace their paths around cooling suns. But even those motions are finite. Stars will exhaust their fuel. Galaxies will grow dim. The mass in galaxies will be more and more locked into compact remnants. White dwarfs, neutron stars, and black holes. On these scales, orbit becomes something slow and fragile. Stars and remnants tug on each other, scattering, sinking, sometimes falling into black holes or being kicked out into intergalactic space. Energy spreads out, bit by bit, as gravitational interactions redistribute it. In the far future, the last luminous stars will die. The night will become a scattering of embers. The remaining orbits will be mostly those of objects around black holes, small, tight, and short-lived on cosmic timescales. And even black holes, as we've seen, are not eternal. Through Hawking radiation, they slowly bleed their mass back into the universe. When the last black hole evaporates, there will be nothing left massive enough to serve as an anchor. No planets, no stars, no galaxies. Only a thin mist of low-energy particles spreading out into an ever-expanding, ever-cooling cosmos. In such a universe, orbit loses its meaning. There is nothing left to circle around. No deeper gravitational well to fall into. No structure to bind. Just particles drifting apart forever in a flat, dark ocean. Orbit built the universe, and one day, orbit will end with it. But that is not where we are now. Right now, the universe is in a strange middle age, old enough to have built complex structure, young enough that gravity still sculpts grand patterns. Everything orbits something. A stone thrown from your hand, a satellite circling Earth, a planet falling forever around its star, a star tracing a silent curve around a galactic center, a galaxy sliding along invisible threads of dark matter. Orbit is not a rare special effect. It is the default solution when motion meets gravity. It is how structure persists without collapsing entirely. How the universe manages to build complexity instead of simply allowing everything to crash inward in one catastrophic pile. Orbit is the compromise between gravity's insistence and inertia's refusal. It is how the universe says, you must fall, but you may fall gracefully. Every orbit is a story of balance. A planet balancing the pull of a star against the speed that would fling it away. A star balancing the gravity of a galactic core against its own momentum. A galaxy balancing on the invisible scaffolding of dark matter. A cluster of galaxies balancing on the edge between mutual attraction and the stretching of cosmic expansion. None of those balances are perfect. They wobble. They drift. They can be broken. But they last long enough for stars to live, for planets to form, for oceans to fill, for life to ask questions. That impermanence doesn't make them meaningless. It's what makes them miraculous. For billions of years, orbit has been the framework on which everything we care about was built. It gave stars their neighborhoods, planets their stable skies, Earth its seasons and climate. It gave our ancestors enough continuity to evolve from single cells to creatures who can put equations on paper and launch machines into orbit on purpose. Because that's the other side of this story. We are not just passengers. We have started to touch the currents themselves. When we put a satellite in orbit, we're doing something profound. We're not fighting gravity, we're joining it. We light engines not to escape falling, but to fall better. To give an object just the right sideways speed that it can share in the same graceful free fall as the Moon and the Earth. When we send a probe to Mars or to Jupiter or beyond, we write a trajectory into the language of gravity and let the universe do the rest. We sling spacecraft around planets, borrowing momentum, giving momentum back, surfing the curves of space-time like a ship that has finally learned how to ride the waves instead of being smashed by them. For the first time in the history of this planet, one of its species has begun to treat orbit not just as a prison or a backdrop, but as a tool, as something to work with, as a path. We have walked a very specific sequence to get here. Gravity collapses a cloud, stars ignite, planets cool, orbits stabilize, seasons pulse, chemistry stirs, life emerges, brains evolve, hands build, eyes look up, minds connect the falling apple with the falling moon, the orbit of Earth with the flow of time, the structure of the universe with the direction of history. And then, having understood a little, we begin to act within that understanding. We are made from the products of stellar collapse, bound to a world kept alive by internal falling, orbiting a star whose own fall will one day end us, inside a galaxy whose orbit around the cosmic web is already being shaped by dark energy. We are nested inside orbits, stacked on orbits, falling inside, falling. Yet, in this tiny sliver between the universe's smooth beginning and its still ending, we get to exist in a zone where orbits are stable, where stars are steady, where planets hold oceans and air, where the sky overhead is both predictable and full of mystery. We get to ride this curve and understand that we're riding it. Right now, as you sit, as you breathe, as you listen, you are orbiting around the sun, around the galactic core, through the cosmic web, through time itself as gravity writes the arrow of entropy into the future. You are part of that endless curve, not watching from the outside, but within it. Always moving, always falling, always orbiting. Orbit is the quiet order hidden in the vastness, the skeleton beneath the chaos, the line that gravity draws through the dark. And for a brief, bright moment, we get to ride that line and call it home.